Hey guys, my name is Ned Shapiro, and tonight we'll be tackling a redox reaction problem in General Chemistry 142. The specific problem that was assigned to me states, for the reaction below, write out and balance the half reactions, identify which is the reduction, which is the oxidation, provide oxidation numbers for each element present, and write the full reaction, being sure to indicate how many moles of electrons are being transferred during the course of the reaction. So immediately, let's just take a look at the reaction given to us. It states O2 gas plus H plus zinc goes to a liquid water plus zinc 2 plus. And we can see by the outlay of this question, I use color coding to kind of highlight some of the steps that are presented in the outlay of the question. Step 1 being providing oxidation numbers to each element present. O2 is diatomic, meaning it's on its own, it's not bonded to anything, and therefore carries an oxidation number of 0. H plus, while seemingly on its own, not bonded to anything, carries a charge, and because it carries a charge, that's what gives it the oxidation number of 1. Zinc is on its own, there's no charge, it's a neutral atom, carries an oxidation number of 0. On the product side, we have a neutral water. An oxygen in this compound carries an oxidation number of -2 because it's bonded to the hydrogens. Hydrogen, therefore, needs to cancel out this -2 oxidation number. We're given 2 hydrogens, therefore, each hydrogen will carry a +1 charge. 2 of those will be +2, which cancels out the -2. And we have a zinc 2 plus, which has an oxidation number of 2 because of the 2 plus charge. Great. So we provided oxidation numbers for each element present. So now we can move on to step 2, which is write out and balancing the half reactions. So I highlighted it in green, and what we're first going to do is we're going to write out the unbalanced half reactions. Here we see zinc. Zinc is clearly associated with the zinc 2 plus, and we see that the atoms are already balanced. There's 1 mole of zinc on the reactant side, and there's 1 mole of zinc on the product side. However, we need to make sure the charge is balanced as well. And in order to do this, we'll add 2 electrons to the product side, therefore canceling out the 2 plus charge and giving us a neutral zinc on both. This half reaction is oxidized, but we'll get to that in step 3. The second half reaction shows O2 paired with H plus, creating water. Unlike the first half reaction, the atoms are not fully balanced. Because we have 1 mole of water on the reaction, or on the product side, we're given 2 hydrogens and 1 oxygen. And on the reactant side, we're given 2 oxygens and 1 hydrogen. Therefore, if we double the water concentration of the product side, we get 4 hydrogens and 2 oxygens. And by adding 4 more hydrogens to the reactions and keeping O2 the same, our atoms are balanced. However, on the reactant side, we now have a +4 charge, and with the neutral water on products, we need to get rid of that 4 plus charge. And we do this, like we did in the first half reaction, by adding 4 electrons to the reactant side. So great. The charges are balanced on each, the atoms are balanced on each, so now we have 2 balanced half reactions. For step 3, we're going to talk about what is being oxidized, what is being reduced, and why is this happening. Zinc is oxidized because it loses 2 electrons to form zinc 2 plus. Zinc is a metal that readily loses electrons to form positively charged ions, which is why it is a good reducing agent. In this reaction, like I just said, zinc is oxidized, losing 2 electrons to form zinc 2 plus ions. The reduction half reaction involves oxygen, which is gaining electrons and going from an oxidation state of 0 to -2. Oxygen in water has a strong affinity for electrons and readily accepts them to form negatively charged ions. Okay, now we can kind of dive into the final step of this process. We'll take our 2 half reactions that we just balanced, and the focus of this step is canceling out the electrons. In the first half reaction, we're given 2 electrons. In the second half reaction, we're given 4 electrons. We need these to cancel because one's on the reactants and one's on the products. So in order to do this, the zinc half reaction, we multiply by 2. The 2 electrons that we previously had now it'll become 4. And this is a step you really got to be careful in, because we're not just multiplying the electrons by 2. We can't just multiply the products without multiplying the reactants by a whole number. So we need to also multiply the zinc and the zinc 2 plus by 2. So we get 2 moles of a solid zinc and 2 moles of zinc in aqueous solution. And now that we have a balanced half reactions where the electrons cancel on each side, we can add up our reactants and we can add up our products and we can get our complete reaction. After completing this final step, we can get our final answer of 2 solid zinc atoms plus O2 gas plus 4H plus goes to 2 moles of zinc 2 plus and 2 moles of liquid water. So to just quickly debrief the question that we examined tonight, we're given a redox reaction problem and we're asked to balance the half reactions, identify what is the reduction and which is being oxidized, provide oxidation numbers for each element present in the given reaction, and to write the full reaction, being sure to indicate how many moles of electrons are being transferred during the course of the reaction. I solved this problem by color coding and by creating a step-by-step process where we first provided oxidation numbers, then we wrote out and balanced the half reactions, then we defined the oxidation and reduction and explained why this occurred, and finally step 4 where we eliminated the electrons and got our complete reaction after balancing our reactants or by adding our reactants and product. And remember, when you're multiplying to get rid of the electrons, you multiply the entire reaction by the number you're multiplying the electrons by.